How many people have come? କେତେ ଜଣ join କଲେ? So Renu madam, we will wait for a couple of minutes. You are mute.
Sorry, sir. Sir, we'll wait for some time. Or sir, we can start. The people will be joining, sir. But we also can, sir.
Professor P.K. Misra, has he joined? Already he has joined, but he is
Yes,
mute.
sir. Sir has joined, sir.
I have talked to him. He has joined. Today there is some difficulty at this end because our NAC visiting is going on. So our faculty are actually busy in that. Anyway, but this was well planned earlier.
But you are anyway recording it, so people.
It is being recorded, and hope actually will not have any objection if we share the recorded thing.
No. My records are always on the YouTube also. Students learn from that.
Good.
I mean, students from Nigeria and Ecuador have comments done and masters with me looking at my videos.
No, it is very good. Actually, this is the advantage with younger people like you, not for old timers like us, who are actually born in slide rule days.
No, but this pandemic taught us a lot of things.
Yes.
So we'll start. We'll start, sir.
We start, huh?
Yes.
Okay. Welcome to 8th Distinguished Lecture Series being organized by INA Bhubaneswar Chapter, SOA University, and IMMT Bhubaneswar. And this lecture series we have started in December last year, and every month we are going to have one or two lectures. And this month we'll have 3 lectures. One on 5th, next one is 7th, and on Technology Day on 11th. And what is, I'm also happy to say that this December, Bhubaneswar chapter will be organizing the National Convention of INA here. And most likely, the student convention will be there in August 2023. So this is a very small chapter. We have associated with our people from different places, but still we are trying to do whatever is possible within our limited things. Now, here, first of all, I will request our Vice Chancellor, Honorable Professor Ashok Kumar Mahapatra, to speak a few words about our university. It will be followed by a short lecture by Professor Sudarsatya Basu, Director of IMMT, about IMMT, because they are our, co-organizers for this series of lecture. After that, we'll request our Dr. Amiya Ranjan Mahanti or Professor Amiya Ranjan Mahanti, who is actually head of Mechanical Engineering Department. And he happens to be a graduate of, REC Rourkela. So I am also graduate of REC Rourkela. And the professor actually who will be introducing him is Professor P.K. Misra. He also happens to be the REC Rourkela, and he has been also our Professor Mahanti's colleague in IIT Kharagpur. So with this few words, may I now request Professor Mahapatra to say a few things. He had a very busy day. Still, actually, he could make some time to be with us. Professor Mahapatra, please.
Jai Jagannath. Good afternoon. Professor Basu, Professor Acharya, our Chief Advisor and also the Chairman of Odisha chapter of ANA, Professor Mahanti, Professor Misra, Dr. Renu Sharma, Professor Nanda, Pro Vice Chancellor, all the distinct participants, mostly are the faculty and friends. I think it is a very interesting thing that Professor Acharya has started his lecture, and it is going to be available in the YouTube. When I was talking to our NAC team that we have started this international lecture, they were interested to know who are the speaker in this international lecture. Then I told we have a SOFL and SOAL, SOA fortnight lectures and also SOA weekly lectures. So we have now weekly lecture, fortnight lecture and international lecture. I think that has going to enrich our faculty and students. So I thank Professor Acharya for this. I think coming to university, our university, baby university, started 2007. But if you take our SOA Trust and the IT year, it started in 1996, about 25 years back. And in a period of 25 years, and university is a period of 15 years, now reached 20 ranking in the NRF ranking of 2021. And our engineering ranks 31 and medical ranks 20 and dental institute ranks 14. So this year we are trying to get law and agriculture and management to be participating in the NRF ranking. But I must thank Professor Manoranjan Naik for his vision. The vision was quality education, research and innovation, and it has to also socially related topics which can enrich the states like Odisha and neighboring states of India. So to some extent, we have fulfilled the aspiration of the people of this region. In 2009, we are ranked A+ by NAC. In 2015, we also ranked A+, the highest grade, and we also have a very good scoring in world ranking and QS ranking. In world ranking, we're 800 plus university, and QS ranking, we are 600 plus ranking in the world and 400 plus ranking in Asia. And if you look at the engineering and computer ranking, they also are in 600 plus brackets. So I think we have a huge number of outside students. If we look at the student proportion, 2/3 students are from outside Odisha. And our medical students come all across India because there are a lot of demand for good medical colleges, because only 20 medical colleges can only score 50% mark. So even you have to spend little more money for your tuition fee, it is worth to go to a better university than that of having a MBBS, which is not a very good university. So I think across the specialties, it's important to have good basic graduation education. If your foundation is not good, and either you will be a good postgraduate student or you can be a good professional. So it is very, very important to understand how the university has to play an important role in producing quality graduates and postgraduates and postdocs. In that context, we have done very well. And I think in this ranking, we are expecting to do well, because till now, whatever has been happening yesterday and today, they are very happy because we have been able to project our good work we have done, our research laboratories, innovation and skill development lab, and outreach program. Today, our NAC team had gone to see our students' adopted villages. They had gone to see the agricultural farm, how they manage. So they wanted to see the outreach program, how our students not only involved in education and innovation research, but also socially related topics and context of Swachh Bharat, nutrition, and when we have pandemic, the immigrant laborers were distributed food packets by our NSS volunteer. We have 1700 NSS volunteer and 150 coordinators. So huge number of social workers, those who through either NCC or by NSS. I think I will be defaulting by telling that the vision was good, the implementation of projects are good. In phase wise, in a period of 15 years, we have reached to extent that we are visible in the world, India, visible in India and internationally. I must thank Professor Manoranjan Naik for his vision and for his dedication, and people like Professor Acharya, who are also trying to get international faculty to be our advisory board, and having lectures like this from the very eminent people like Professor Mahanti and many very top people from the world. We are trying to enrich the knowledge of our students and teachers. I thank Professor Acharya, Professor Basu, and all, and our Professor Mahanti are the lecturer today, guest speaker today, and Renu Sharma, Professor Nanda, and all the participants for participating in this lecture program. Thank you very much. Thank you, sir.
Professor Basu, please. Please.
Good afternoon or good evening to all the INA members and those who are attending today's webinar series. I must congratulate our chairman, Professor Damodar Acharya, and we are seeing that the INA Bhubaneswar chapter is every day becoming strengthening itself step by step, brick by brick, and we have come to a stage that we are conducting 2 webinars in a month, and in fact this month will be 3 webinars, as he mentioned, on Technology Day, an additional one as well. I am very happy to learn that this year INA will be hosting, we will be hosting INA in Bhubaneswar with their annual function or annual meet. That will be a great opportunity for all of us to congregate and discuss. And I hope that in future we'll also have physical meeting in SOA or in IMMT or any other education institute in Bhubaneswar where INA organize a half-day symposium or a one-day symposium or webinar or webinar in hybrid mode to attract most of the persons in and around Bhubaneswar and Odisha. I am from CSIR Institute of Minerals and Materials Technology. As the name says, we work on mineral beneficiation, extractive metallurgy, pyrometallurgy, and development of alloys and metals and materials and functionalizations of metals and non-metals as well, and their application in different devices. We work in the area of environmental and sustainability related to these issues, and mining areas, in metallurgical processes, and also in water and air pollution, solid waste management. We work in the area of process engineering, instrumentation, material chemistry, and every field of 4M, we call it mining, mineral, metal, and materials. We also do a lot of societal activities in terms of intervention of science and technology in societal benefits, especially in southern Orissa. And we have done a lot of work in Nabarangpur. We are going to do in Koraput in the coming years with government of Orissa, government of India, and RKVY project. And our previous project was very, very successful. We have about 110 numbers of scientists, about 70 numbers of technical staff, about equal numbers of administrative staff, a total of about 240. And we have equal number of contractual staff. And we generate our budget in a year is about 120 crore. So we almost generate about 50 lakhs per scientist in terms of external cash flow and ECF. So which is very heartening to see, and there are a lot of activities in Orissa and adjoining state where the mining taking place, extractive metallurgy or metal extraction taking place, and we are all part of it, not only all over India, but also in the world. And we will continue to do so, and we'll continue to help this region to grow. We have a startup incubation center. We call it INTEC, Innovation Technology Enabling Center. And recently, we are now incubating about 13 companies in our INTEC, the incubation center at IMMT. Thank you.
Thank you, Professor Basu. May I now request Professor Misra, P.K. Misra, to introduce the speaker today, Professor Ameyo Ranjan Mohanty.
Thank you. Professor Acharya, Professor Mahapatra, and Professor Basu.
Your video is not working. Video is not possible.
All right, no.
No.
All right, now I think so.
No, we are not able to see you. We are able to hear you. Now perfect.
Okay. Okay. Professor Acharya, Professor Mahapatra, and Professor Basu, and my other esteemed colleagues. And I want to introduce Professor Mohanty, whom I know from his childhood, when his father was my teacher. Okay.
So also my.
So I've seen him right from cradle days till he's now a grown-up, renowned professor of IIT Kharagpur. Now, Professor Mohanty graduated from REC Raurkela in the year 1986 with honors degree. And he did his MTech in the Indian Institute of Technology in the year 1988. He was in machine design, but that time I was in manufacturing science. And he did his PhD degree from University of Kentucky in the year 1993. And he worked with many laboratories, especially Ray W. Warwick Laboratory of Purdue University, and he was a presidential fellow there. Subsequently, he worked on what you call noise control and all these things. And as you know, noise is now one of the dominant field of research, because even COVID, we say it is big, say that is aerated and all these things, but noise is many part of it. Okay, it is getting accelerated. That is why all the bands are introduced in any conglomeration using mics and all these things. And it will soon become a practice. In Australia, it has been completely banned. The noise producing in the atmosphere. Anyway, Professor Mahathi is specialized in condition monitoring, and he has many books and especially many chapters. And one of his famous book is Missionary Condition Monitoring Principles and Practices by CRC Press. And has got many awards. And especially if I will tell Chancellor's Award for outstanding teaching in the University of Kentucky. And he has published many papers, more than 150 papers, and he has handled more than 100 research projects, and he is an expert in what you call condition monitoring and signal processing in the country, and his specializations are especially underwater acoustics and all these things, which are very important science. And instead of telling much more about him, let us hear the expert lecture from Professor Amir Ranjan Mahathi. Thank you very much.
So Professor Mahathi, please.
Yeah. Thank you, sir. Thank you, Professor Mishra, for introducing me. At the outset, before I formally start my presentation, let me try to pull out my slides first. Let me share the screen. Is my screen visible to all?
Oh, sure. Perfect.
Thank you. Good
You can
afternoon.
make it full screen.
It is full screen.
Okay, doesn't matter.
It is full screen.
Okay.
At the outset, good afternoon or good evening to all of you. It was an honor and a privilege when Professor Acharya called me that you have to give a talk on behalf of the Bhubaneswar INE chapter. And I can never refuse Professor Acharya. First is because I revere him as a person whose qualities and vision are very rare to find in many persons. And on top of it, he was also my director when he was at IIT Kharagpur. I am pleased to meet or know Professor Mahapatra today, Vice Chancellor of SOE University. Professor Suddhasatya Basu, I've heard of you from IIT Delhi, and it's nice that you are here at IIMT Bhubaneswar. And Dr. Sharma and all the participants, it's an honor really to present this talk on natural materials for noise control through this INE Bhubaneswar chapter. And I must congratulate, and it's a very heartening news to know that Bhubaneswar, finally, we are going to host the INE annual convention in December. So as a member of INE Bhubaneswar chapter, I'll be glad to volunteer my services if required for that. Having said that, let me come back to the topic of today's presentation, this natural materials for noise control. This has actually evolved out of a research which we did in Kharagpur about 1.5 decades ago. In those days, you know, there is a national jute board. They gave many proposals to IIT, many topics to IIT Kharagpur, and we put a proposal that why not we explore the properties of jute material, which till then was actually being used in gunny bags. And they were also losing market because of the polyester group or the polymer group. They wanted to pack onions and potatoes and cement in polythene based bags and not jute material. But then we thought, why not we look into the other properties of jute? Because there were some scantily few literature as to it has good porous or absorbing properties. So incidentally, our group was almost the very first in the world to explore the properties of jute material. And it was very heartening to know in our lab when we found out that its acoustical properties are comparable to that of fiberglass. And those of you who have handled fiberglass, you know it is how irritating, it is carcinogenic, it is very itchy to hold, and it is finally glass. And if they go airborne, it is dangerous to even breathe. So jute was a natural choice. And then of course, I will tell you the whole story. And as I see, there are participants and faculty members from other institutes, and this video, which is being recorded, could be used by students for learning. I thought I will introduce you to why at all we do noise control. And that is what I will talk about in principles of noise control. And then you will see the need of materials. By materials, I only do not confine myself to natural materials. Fiberglass, concrete, etc. can also be used, but we will see where these natural materials come to an advantage. And then some of the basic material processing, natural material processing, their properties. And then you will see in acoustics or in noise control, we require two very important properties, that is absorption or blocking. And then I will conclude with few case studies out of my consulting experience with noise control in refrigerators and HVAC of an automobile, and which is today in the market, by the way. And then, of course, what is the future of natural materials? So I will try to complete within enough of the allotted time. And if I exceed the time, Dr. Sarma, you can always jump in and tell me to fasten up. I will tell you, right from your high school physics, all of you know there is some machinery which is producing noise, which is this source of noise. It is the machine itself. A good designer makes sure that the machine does not produce or radiate a lot of noise. And finally, this receiver noise is which usually we have a control. It is finally our ears, our microphones, which we record for regulatory services requirements. But this vibroacoustic energy from any machinery which is under operation requires a path. That is what I have written in red. Path through which this energy is getting transmitted. And this path can be air when we are talking in a room full of, it is basically airborne. But talking about underwater acoustics, inside water, in submarines, in ship hulls, it is the fluid. So the vibration energy of a fluid of a ship or a submarine goes through the fluid. And also, as you all know, those of you who understand basics of vibration, plates, beams, columns, they all transmit energy, vibroacoustic energy. So a layman would say, well, I can reduce the transfer of this vibroacoustic energy if I do something to the path. That is, I can block the sound waves, I can block the vibration, and that is why very basic principles of noise control is you have good vibration isolators. If there is no vibration, there is no noise, unless we are talking about aeroacoustics. But let us talk about focus on the path, where we can, as you can see here, I have shown a general fiberglass and concrete. Fiberglass will absorb the sound waves, concrete will block the sound waves. But then we thought, why not we look into the jute material, and you'll come to know why jute material. And then we will see what kind of engineering has to be done to this jute based plant, which is abundantly available in Bangladesh, in Bengal, etc. Okay. So before I go into basics of principles of noise control, just to make you all aware, people, of course, nowadays, Professor P.K. Mishra was mentioning about this loudspeaker, etc. But in general, in any country, particularly in India, transportation noise is there, machinery noise, and of course, we know the big story about firecrackers. Now, when we were kids, we used to have fun with chocolate bombs. But today my sons cannot buy chocolate bombs. Okay, they are not available because the regulations have come into place. Okay, and so the government, our CPCB is Central Pollution Control Board, they have made regulations as to what is the acceptable level of noise. Of course, we have the rules for the public address systems also. And I happen to be a member of this National Committee on Noise Pollution Control of the CPCB. So we had drafted some of these standards as well. And these standards are declared by a Gazette notification at what is the level which should be there in an environment. So this calls for the designers. Now, I'll tell you why at all I'm telling you this. For example, nowadays, if you look at a DG set, it comes with a canopy. So canopy is actually used to reduce the radiated noise so that the DG set adheres to the noise regulations given by the CPCB. And one term, this numbers, it is an equivalent noise over a period of time. This is calculated or this is measured by an integrating sound level meter. You must have heard in the news, some police station in Delhi or UP, DB meter kahan hai? Humko to DB meter use karna nahi aata hai. But there is a little physics. You don't have to worry about it. But these standards, these are for India, that if I zone an area A, B, C, D in the daytime, which is 6 a.m. to 10 p.m. and nighttime 10 p.m. to 6 a.m. This should be the maximum LEQ equivalent level which should be there. And these are all available in the Gazette notification as per the CPCB. Now, this is defining the limits of noise which can be radiated by any product. And today, if you talk about products being made by automobile companies, if you go to buy a car, people will say, "Na, ye bahut awaaz karta hai." I do not like the feel of the sound inside it. If you talk about domestic appliances, my wife always complains, what kind of noise control you are doing if you cannot reduce the mixing noise in the kitchen? Okay. Incidentally, we have reduced the mixing noise as well. Currently, the sound absorbing materials which are being used, fiberglass, all artificially made fiberglass, polyester fiber, polyurethane foams, etc. They are good, they are bad, because if they catch fire, they give out a lot of toxic fumes, and they are expensive. Chemical processing is required. And of course, some commonly used sound barrier materials where we can block sound. You have a big bunker, concrete walls, thick steel sheets, lead sheets. The more heavier it is, the more sound it will block. Keep this in mind. Okay. And of course, when you're talking about sound absorbers, there are applications are everywhere, from the HVAC lining duct, from different locations in the automobile, in machines. So there could be different types of material, micro-perforated fibrous materials, metallic foams. Material science people, they are developing a lot of material foams, metallic foams, because they can withstand high temperature. Okay. Polymeric foam, natural wool, and we are talking about the felt made out of natural materials. So different types of porous materials can be made, and we thought that why not we explore the natural fibers, because of the climate change. We could have greener technologies, and today natural fibers are available from jute plants, from coconut coir, sisal, flax, hemp. Okay, in different parts of the globe, I have seen in Indonesia, they use a lot of flax. In Brazil, they use sisal, papyrus in Egypt, and coir and jute now in India, depending on the availability of the natural plant. So I will specifically stick to jute because that is what introduced me to this topic. And that was in somewhere in 2007-8. We had a student who worked on this, and then we were almost our research group got an instant recognition in the world because we could apply it to reduce noise in appliances. And I'll come to those story later on in my topic. It is very cheap, jute used to be 20 rupees a kilo. It is biodegradable, renewable, and easily available. But this plant has 65% cellulose and about 12 to 14% lignin. I must also acknowledge when we got into this area of jute, we took a lot of help from our material science department because I'm not a material chemist or an expert in that area. But my colleague in the material science department of IIT Kharagpur, Professor Basudam Adhikari, he helped me with a lot of this chemical processing. So just to give you an idea, jute plant, along the river Ganges in Bangladesh, this jute fiber, jute strands are made, and you can make a lot of things. You can make composite boards. You can use just jute fibers, jute felt, treated felt. If you go to the mills, jute mills around the Calcutta or the Howrah belt, you will see all they do is make felts. Felts are being used in sofas, being used in gunny bags, etc. But nobody really looked into the acoustical properties because you see, if I take the fibers, they are good absorbers because there are pores in them. But if I can make composites out of them, they become heavy, and then they can be used as transmission material or transmission loss material. We looked into some of the SCM images of the jute fiber. There's a lot of very coarse strands in the jute fiber, okay, under magnification. So it has to be done, a lot of cleaning has to be done, and we can manufacture jute fabric based just by hand layup and a little pressing. Okay, but when the pressing forces were high, we have a composite applications lab we used to have in our chemical department, where we use their 3,300 ton hydraulic press for compression molding and made jute felt panels. These are composite panels. These are material. Let me tell you, there is a secret recipe in this material. It is fire retardant, it is stable, and it will adhere and bond, and I'll get a jute composite material which can be used to block sound. I'll show you the example when we did that in the case of a refrigerator. And this jute bonding is proper, and that is why you can see in the SCM images between the matrix and the jute fiber. But as in any material which is being developed, if I go for any practical applications using them, the end user would look into its properties. Of course, jute, people would like to know what are the chemicals you have added for the bonding. If there are no trace elements, no elements which are harmful. Having kept the material properties aside, it was most important was the fire retardant properties, because we wanted jute to replace the traditional fiberglass used in automobile. And today, any automobile, any material you put in automobile, it has to undergo all these fire tests, either from the Federal Motor Vehicle Standards or the UL standards. They have their horizontal test or the vertical test. So these materials have to be tested. And this is due to anybody, any technique or any material which you have developed. If it has to be applied any product, it has to go through a series of tests and certify all regulatory requirements. Trace elements, fire, mechanical strength, of course, in jute. Further requirement was the acoustical properties. Are they as good as fiberglass? Can they absorb sound as good as that? So these are all requirements. So as a materials developer, we did all those tests for the materials. So limiting oxygen test, when we had this natural rubber coated with jute composites, its LOI is 29.3%. So it is never going to burn on its own, because in air, oxygen is 21%. It requires 29.3. So it will self-extinguish. That is the best part about it. Flame propagation, when we tested this sample, compare with, we did apply 1% sodium phosphate to the material which we manufactured. It extinguished 7 times. It passed the FMVSS standard and also the UL test standard. So having done all this material test, we were confident that the material jute-based composites which we developed can replace the fiberglass. In fact, the maximum light absorption is also very good, very less being good. Okay, and this is the smoke density test of the sample of the fiberglass and of the jute, just to give an example. And these were all done in our laboratories, be it in the chemistry department and material science department at IIT Kharagpur. But then it is not only the fire or the chemical, but comes the mechanical strength for a material which is being developed, both in terms of the, because these materials have to be kept in places where they require an appropriate tensile strength, flexural strength, 3-point bending strength, and of course the transmission loss. So these samples were made. Normal UTM standards are used in a tensile test. Okay, and of course, we had different types of treatment. If you see here, type 1, type 2, type 3, type 4, you see the stress strain characteristics of this material, and they were as strong as they need to be for a particular application. And these were never documented earlier, and we are again the first to document them. If you look at the tensile strength, okay, with a certain alkali treatment and under UV light, we could get the dynamic modulus about 418.78 MPa and yield point strength so much in tensile and again in flexural. So we did all these kind of studies to find out the best way to treat and develop jute composites which will be used for noise control applications. And this is just to show the lignin which is there on the strand of the jute fiber. And because see, jute loves water, if you have seen, jute plants grow on the river banks of river Ganges, and when the Ganges overflows, the jute fields are flooded, but the jute does not decay or disintegrate. Okay, so the advantages of jute composites is one of the strongest natural fiber, good insulator, obviously, low cost, 100% biodegradable, and it is non-abrasive to processing. So we really had a very good material available to us naturally. So why not use it for noise control? Why not use it for sound absorbing or sound blocking is the story which we get so far. Of course, the disadvantage is because they are hydrophilic, this jute prevents good adhesion between the matrix and the fiber. That is why a little bit of chemical pre-treatment has to be done to this material, and there is a recipe which we figured out, which we do that, we wash it, do a certain alkali treatment with sodium hydroxide, and we mix certain chemicals, and so that we get a good bonding. And this is what is required. So if this recipe is given to any jute manufacturer, and I have given it to many industries, and which they are using it now to develop materials out of jute, which can be good composite boards or good absorbers. Of course, and I will not go into details of this ultraviolet discharge treatment, etc. Of course, we did a biaxial state treatment, and so that there is better alignment of the molecule changes and exposed contact area for better alkali treatment. And this was all done in the lab at the lab level, and then we transferred the technology to some companies. I will come to that later on. Now, just to recap, so far we have felt the need of noise control. We have to do something to the path that is either airborne or structure-borne. For the airborne, we can either absorb them or block them. And you have seen how natural material like jute can come and play a role. And then, of course, we have to measure the acoustical property. This is a standard ASTM E1050 standard, which is used to measure either what is the amount of sound absorbed or sound blocked. No, all you require is A, B, C, D. There are those students who are here. There are 4 unknowns. So all I require is 4 known quantities, 4 microphones. And this is done in an impedance tube. It's a plane wave impedance tube. So depending on the microphones P1, P2, P3, P4, I can find out A, B, C, D. And from the transfer matrix method, I can find out the properties. Okay, you have to know is X1, X2, X3, all these distances, and you have to do a simultaneous FFT analysis. So by knowing this pressure P1, P2, P3, P4, solving these equations, I can find out A, B, C, D, and plugging back A, B, C, D, which I have written here as T11, T12, T21, T22, I can find out the transmission loss, and I can find out the sound absorption coefficient. It's a very simple experiment. Again, I have a role here. Sometimes in my PhD in 1991, it was my first conference paper where actually I had developed this, and I had I developed it with my professor, and we had gone commercial to this tube. And today, of course, in every lab has this, and everybody makes them, and then there are many commercial companies. And this is for a very standard, it's a 1977 paper where you require, if you look up a sound wave, it goes in 2 directions. One is incident and one is reflected. So if I can find out the incident and reflected wave, I can find out the impedance of the material. And these things are also used in ultrasonics. Anywhere you need to find out the material properties, all you require is its impedance. Okay, and this has been taken care of to find out these sound absorbing properties. These are typical sound absorbing materials which we tested in the lab. You can see the jute fibers, you can see coir, you can see waste cotton, Celotex, wool, sponge, etc. And these are the properties. If you see the normal specific sound absorption coefficient as a function of frequency, you see jute fiber is pretty much comparable to that of fiberglass. Okay. And in fact, we discovered this first time in somewhere around 2008. And that is when I got excited that it has so much of potential. Why not we use it for engineering applications? And another thing I must tell the students who are here, for any fibrous material, if you blow air through it, there will be a pressure drop. And this pressure drop to the velocity is something known as the flow resistivity. And those of you who do not have such expensive equipment to measure the sound absorption or the transmission loss, you can, for fiberglass material, from empirical relations, once you know the flow resistivity, which is very easy to measure even with a manometer and an anemometer, you can find out the sound absorbing coefficients. Another little bit of physics which I need to give you here is the transmission loss. So if a sound incident wave is coming in, some will get transmitted, some will get absorbed, and some will get reflected. So this transmission coefficient is defined as the transmitted by the incident. And we did that same for the jute materials also. And actually you will see the transmission loss will increase with frequency. That means there is actually a minus sign. So with increasing of frequency, the sound absorb will be high. So I don't know if you have heard, if somebody is playing a loudspeaker, music in a loudspeaker in an apartment complex, you will hear the low frequencies dhum dhums. Okay, because they are low frequencies. The transmission loss is poor. High frequencies, you will not hear that. Okay, so just keep in mind. So our challenge is to block the low frequencies waves. So for that, all you need to do is increase the surface density. Anything you make heavier, heavy concrete walls, double panel glass walls, they will steal noise. I don't know, those of you who have stayed in 5-star hotels next to the highways, you can see the cars or the automobiles, particularly you can see it in Germany. You can see the vehicles moving at high speed, but inside your hotel room, you will not hear them because they are thick panel sound proofing transmission loss, glass materials. So the transmission loss of concrete is about 53 and 6.4 mm steel plate is 36. So jute also we measured, and this is a standard setup which is known as the alpha box. All we require is a random way. We put a material here. This is the sample holder, and we see the difference in the sound before and after the material, and that is how you can measure the transmission loss. This again very cheap way we developed it in the lab. Okay, and the transmission loss of jute is as comparable to that of steel, about 6. This is about 30, and the thickness is about 3.25 millimeter. Okay, so you see the transmission loss of jute is that we made was also comparable to that to the steel plates. Now, this was our first application wherein we tried to reduce the noise radiated of a clothes dryer. Okay, this was our first experiment of the engineering applications of the developed jute. Now, what we did was we found out that this motor here and the blower on the rear wall of the dryer is radiating a lot of noise. So what all we did was lined it with jute felt, and there is a drastic amount of reduction. And of course, the company who had sponsored this, they told, "Sir, आप थोड़ा वो एक ये बना दीजिए, एक cover बना दीजिए, उसमें हम design कर देंगे. It'll look good when you are using it. You can put it back." Okay. And of course, in my old labs, I had replaced the ceiling tiles with this jute-based fibers. Of course, now we have got a better office room and lab. But just to demonstrate that these jute fibers are equally good as Solitex board, and they are naturally occurring. Okay, and those of you who are again very important in noise control, please remember is noise source ranking and characterization. I need to, somebody asks you, reduce me the noise of such and such product. The first step, all you need to do is find out the, excuse me. Hello. Is there an echo? Somebody, you need to mute yourself. Hello. Yeah, is it clear now? Just to answer the, just to pose a question, how do I start noise control on a product? Your first job is to find out the area where the radiated noise is the highest. Okay, and which we did using an instrument called as sound intensity level, because it's a vector quantity, and we found out the rear areas near the blower motor was the high place of noise, and which we took care. And of course, you have to again characterize it in terms of frequency, because you would have seen the materials do not behave identically at all frequencies. For the same thickness of material, it is a poor absorber at low frequencies and a better absorber at higher frequencies. So we have to find out or tune materials to a particular frequency. This is a close-up view of that jute felt which we used. And of course, the overall reduction was about 4 to 5 decibels. You can see without treatment and with treatment. And now, having done this somewhere around 2011 and 12, a major company in India approached us that we have heard that your jute material is very eco-friendly. Why can we not do something to the refrigerator noise? So this is the details of the refrigerator. I'll not go into. This is a 3-bore refrigerator. So as I was telling you, the noise which we hear is because of the compressor. Okay, it's all basically vibration, and then there is some amount of airborne excitation, and of course the evaporator fan. Of course, the evaporator fan which is occurring inside the evaporator chamber does not radiate out, because if you have good door seals, and that is true in automobiles also. You would have seen when you're driving at very, very high speed, all you hear is the airborne noise of the tire noise. You do not hear the engine noise anymore. because engine noise is nicely, it's a low frequency noise, it is nicely encapsulated, and there are good vibration isolators. So it is particularly at high speed vehicles, it is actually the high speed airborne noise. So this can be only effectively reduced by having proper seals. And of course, the student being student, they were excited that they wanted to do a CAE simulations. But we did the simulations, and these are the on the left hand side the CAE simulations, which any product developer nowadays does. And what we did was we also did measurement, and you will see here the rear of the compressor was radiating about 48 dB, and the evaporator fan was about 40. So we put certain measures to reduce the compressor noise in terms of putting dampers, putting proper isolators, etc., and in the damping in the evaporator plenum. Okay, and then I will show you something else in another figure here. Let me show you. What we did, this company, I'll come to back to the remaining slides. To reduce the evaporator fan, if you look at a refrigerator, this is in their plant in Ranjangaon in Pune, where we put our composite panels around the evaporator panel. And actually, this is the sheet metal steel onto which when you open a refrigerator door, you see a white plastic casing or a polythene casing. Between that white polythene and the sheet metal, they put in foam, which are used as thermal insulators. But these foams are not good acoustic insulators. So what we did is we put these barriers, and they could reduce the evaporator noise by about 5 decibels. And now the NDA is all over, so I can say it is a Whirlpool of India, and because the waiting period is over, and they were so happy with this technology that their North American plant, they in fact flew me to Benton Harbor in US at their expense, and they took the technology from us. And in US, they were using fiberglass, which used to cost them about $6. Okay. And we reduced it and made it less than $1, less than 50 rupees or 60 rupees then. And they took the technology from us, and they are using it in their refrigerators for noise control, even in their compressor. Okay. And particularly, see this without treatment, this is about 42 decibels, and we reduced it to about 37 decibels. The noise reduction was about 5 decibels. And let me tell you, particularly in small dwellings and in small flats, if a refrigerator is there in your hall and somebody is sleeping next to the hall in their bedroom, the compressor in the night is an irritant. It disturbs your sleep. Okay. And the refrigerator manufacturer, they want to measure the sound quality. It is not only reduction, but is it pleasing? And that is a requirement. This is in our laboratory. In fact, this is in our material testing laboratory. You can see a human torso where we are recording the sound. And this is the refrigerator without treatment. We have certain sound quality. These are certain parameters by which the noise is perceived. A better sound quality means the product is nice to hear to, and that is what is required nowadays by many manufacturers. It is just not only noise, but it should be pleasant. You go and listen to an air conditioner in the showroom. इसका आवाज मुझे अच्छा नहीं लगता है. Though the noise may be less. Mixie, washing machines, the same thing applies. So people, today's customer, they are very conscious about sound quality, and this is very, very much there in auto industries. I would like to know the quality, and this has kept another challenge to we noise control engineers. People today, the electrical vehicle manufacturers are getting a feel, this thing does not make any noise. So if you're driving a Tesla, you must get a feel that it is a powerful vehicle. In fact, the very first day, about a decade back, we had a colleague who bought one of those electric scooters. I was standing in the parking lot, and suddenly he whisked by. I told him, "Kya hai? Awaaz hi nahi kar raha." So sometimes the people also do not like that vehicle has to make a certain amount of laws because we relate to it. For example, I'll just give you an example. All of you must have heard of this Royal Enfield motorcycles. They make that loud duck, 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 the traditional noise. Imagine the market, what would happen to the market if this Enfield noise was replaced by a Scooty noise? Okay, so you can understand. So sometimes for market branding, people do not want to lose their traditional branded noise. We talk about those old Yazdi motorcycles or a Rolls-Royce engine or a BMW car or a Mercedes car. There's a difference in the sound quality, though they, in terms of decibel levels, they may be same. So this is another thing as noise control engineers we have to be careful about. Of course, all said and done, you may reduce the noise, but I must not change the cooling capacity of a refrigerator. That is true for any product. I can put a muffler, but there should not be an increase in the back pressure. Same is true for the refrigerator. So we monitored the temperature. There was no change in the temperature, and they were happy about it. So I have given you a brief of what kind of applications you can do with jute. And today, let me tell you, when we published first paper in 2008, we are hardly one or two in the entire world. And today, if you go to Science Direct, so many publications are there in natural materials coming from all across the world. I will come to the last example. How am I doing in terms of time, Professor Sharma?
Another half an hour is there.
Another half an hour. Okay. Yeah, I will come to the another example which we did. This is for a major vehicle manufacturer in our country. See, this is an HVAC in a vehicle. Let me explain to you what happens. So the driver is somewhere here. Okay. The cold air comes, these are the sides and in the front, and there is a blower, there is a condenser outside in the engine, and there is an evaporator coil. This is a better view. First here. Okay. This is a side view of this. The person here somewhere here, the cabin vent. So what happens? The air which is coming, there's a separate refrigeration circuit. The condenser is elsewhere. This evaporator is the cold unit. So what happens? The air which is sucked from outside, okay, fresh air comes in, and this radial blower throws it through this evaporator. So this air becomes cold. And there is also a heating. So in your car, you must have seen that there are some knobs nowadays, of course, they're electronically controlled, that they will move these flaps. Okay, so if you want only hot air, this flap will be cold air evaporator will be kept at a low temperature and heater will be on. So all you require is then hot air will come in. And if you want cold air, this will be not heated and you'll get cold air coming from the cabin area. So this kind of arrangements is done. But the most interesting part is this blower, which makes all this noise which is coming through into the cabin vent. So this manufacturer, they outsource this product to an OEM in China. Okay, so this Chinese manufacturer, what they do good amount of ABS molding and put a blower motor, and this comes to the plant in Pune, and then where this is mounted. So we wanted to do something on the prototype. Okay, so what we did, this is in my laboratory, where you can see an exciter here, and you can see a vibrometer here. We are doing an experimental modal analysis to find out its natural frequency. And then this is a tachometer to find out the speed. And this microphone is supposed to be at location where a driver's ear is there. Okay, and that is what is the arrangement. So we wanted to do all evaluations based on to the noise level at this microphone. So if there is a reduction, it will be felt at the driver's right ear. And this is the baseline spectrum at driver's right ear. Okay. And again, for those students who are here, this is a sound intensity probe, okay, where actually there are two microphones. And if I direct that probe to any directions, it is assumed that the sound is coming in this direction. If I turn it around, the sound value will be minus because intensity is a vector. And there is no better technique in the world today to find out sound source rather than a sound intensity level probe. Okay, so please keep that in mind. Sound pressure is a scalar quantity. If I measure a pressure, I can never know where that sound is coming from. I can only know sound at this location is such and such. But for a diagnostics point of view or for a point of view to pinpoint the source, because once I know the source, I can find out methods to control the noise. And so by this sound intensity probe, I could find out it is actually this blower, which is the noisiest, this blower motor, which is the noisiest. Okay. And then we listed many things which were done on the HVAC unit. The blower outlet was lined with 8mm sound absorbing jute felt. All the linings were done with jute felt, foams, a lot of dampeners were used. So with that, what we did, we tried to absorb the airborne path. We tried to isolate the structure-borne path, and this is what we did. Okay. These are some photographic views of the blower. Okay. And you can see even we have used waste cotton, okay, certain materials which can be, the flaps can be lined. So if in fact today, all these materials, today there are many companies who have used such materials, made them fire retardant, and they are commercially selling them for application in automobiles. And the door trim, if you open a door, you see a fabric. Behind the fabric, even cars like BMW are using jute felts, and they outsource it from companies in Calcutta. Okay, this is what the technology is. Okay, and people are looking for natural materials, low carbon footprint, no toxic fumes, and the applications are many, and many commercial companies have come up which are developing not only jute, cotton-based, waste cotton-based materials. I know of a company in Bangalore who are collecting waste cloth. In Bangalore, they have a lot of this tailoring hubs. Okay. All of these manufacture large brand names, Raymond's or Arvind Mills, etc. All their trade name shirts, etc., or dresses, etc., are being tailored at houses in small industrial houses, and there's a lot of waste textile. And I know of my former student who is now a colleague in IIT Delhi. They're using these materials and again engineering them for noise control. Railways are using them for noise control. We have reduced noise control in locomotives of RDS of the high speed, high power locomotives engine. So what I meant to tell you, let me tell you, I did an accidental discovery of the jute acoustical properties in 2008, and this led to development. This led to many projects, both where my students have got benefited, I have got benefited, and we are exploring many avenues and opportunities to use such materials for noise control. Okay, and of course, this is the end reduction is we could reduce 5 dB at the driver's right ear. Okay, and many times these projects we have completed even in a 2 weeks time, because this was very interesting about this product of the HVAC. The prototype was shipped from China to our laboratory. We did the engineering, did the prototype, we shipped it to Pune. Okay, and where they took it forward for manufacturing. So it is satisfying to know that people are using this technology, which is And it is not rocket science, let me tell you. Engineering is not rocket science always. And basics, if students, if you adhere to the basic laws of physics and common sense, many engineering problems can be solved. And again, I tell my students, those who study vibration, if you have understood a single degree of freedom system, or at most a 2-degree freedom system, you can solve 90% of the vibration problems on Earth. Let me tell you, it is so simple, nothing to be scared of. And same applies to acoustics. It is something, nothing but vibroacoustic transfer of energy. I have to block the energy by either absorbing it or isolating it. And that's as simple as that. And these technologies, you talk about submarines, you talk about railway locomotives, you talk about automobiles, home appliances. People nowadays, people are looking for greener, cheaper materials. Okay. Of course, there are many more areas to be explored. One important thing is this combination material. Now, it can do absorbing, blocking. I will add, it can also do damping. And I was just explaining it to you the importance of sound quality in terms of the perception of sound. Whether we feel good, the noise is bad. I'll give you another example to relate sound quality. I'm sure, being in when I was a young faculty at here, I used to stay in a lot of this DRDO. I'll not name anybody. A lot of these government guest houses. Okay, and in the middle of the night, I used to wake up because of a leaking faucet in the bathroom. The tap used to drip, tap, tap. This low noise, but this water dropping noise, it's very irritating to you or to your sleep. So this is what is I meant by sound quality. Even that the noise is less, I do not like the feel of it. Somebody whistles at you at a pure tone, you will be irritated. And that is why alarms are irritating, because your attention is required there. Okay. So you can relate to sound quality. At the same time, some soft music is very pleasant to hear. And this is what I mean. So it is not only noise control. Today, we have to be careful about the sound quality. Of course, in conclusions, I must acknowledge all my present and former students, my sponsors, both from the industry and the government. Of course, my present employer, IIT Kharagpur. We have a very well-established laboratory, perhaps the best in the country, I would say so. That is the Acoustics and Condition Monitoring Laboratory. You can see more about our laboratories and facilities and about lecture at my website, iitnoise.com. And these are some of our sponsors. It is not the end of it. There are many more. Okay. And this is my research group. The sad part about this picture is about 3 years old. This person sitting here, that is B, remains a constant character, but all the students come and go. And that is, as you all know, part of a faculty or a teacher's life. Students come and go, but we have to be there, educate them, and so that they come up to level, and then they can propagate noise control in the society. Okay. With this, I thank the audience for listening to me. And if Professor Sharma agrees, we can go for some Q&A.
Yes, sir. Thank you so much, sir. I would like to invite the questions from the participants. They can unmute themselves.
I can see somebody. Do I know?
Or you can raise your hands also. Yes, Bhavani Sinha, sir. Hello. But I'm not finding anybody raising the hands. So your lecture
Okay,
was
okay,
well
okay.
understood, and they can send you queries in email.
Yeah.
If at all, yes.
Okay. Now may I request Professor Nanda to propose a vote of thanks and summarize.
Good evening, everybody. Thank you, sir. At the outset, I must compliment Professor Mahanti for a very lucid presentation and with very kind of the day-to-day applications of engineering and giving back to the society like noise control we face. And I think this is going to be a menace. I think this kind of control, if it be applied in our all appliances, I think this will be a kind of a game changer in our life and in the society. I believe in MRI machine, many of us have experienced there is a huge noise, and I think it is so kind of troublesome that the patient gets scared to the noise and all. So this is the right, I think, research Professor Mahanti is spearheading for last 3 decades. I think more than that. So that helping the society, and I think studying in depth the vibration and noises in different kind of the materials, particularly. And as technology evolves, I believe the research of Professor Mahanti will definitely help us to find out new kind of gadgets where the noise will be minimized. Already, as you were suggesting in the car, the modern car, the noise is minimized because of his contribution. So here is many often it is asked the research contribution to the society is a direct benefit to the society. Professor Mahanti has highlighted, and he has also produced many kind of graduates, PhD students, master students who have propagated this. I believe there will be a contribution from the India and is visible across the globe. I'm sure India will contribute in this domain to a greater extent. And on behalf of Shiksha Anusandhan University, on behalf of INE local chapter and IMMT, I extend my heartfelt thanks and profuse thanks to Professor Mahanti, who have agreed to deliver and share his expertise to all of us. And even though it is a very common and there is so much deep analysis in it, we could know from it. And I believe all the distinguished participants, including the students, have been greatly benefited. I thank Professor Damodar Acharya, who has taken initiation and motivate many top speakers, including Professor Mahanti today, to, I think, deliver, share his expertise with our audience. I thank Honorable Vice Chancellor, Professor Ashok Mahapatra, sharing briefly about the SOA achievements and the current activities, and thank Professor Basu for sharing the current scenario of IMMT. Thank Dr. Renu Sharma and his entire team for coordinating all these lectures. I thank all the distinguished participants who have spared this evening to listen to this lecture and to this very lucid and very nice lecture delivered by Professor Mahanti. Once again, I thank Professor Mahanti for sharing this. Thank you. Namaskar. Thank you.
Thank you, Omeo, for such a beautiful lecture.
Thank you. I hope.
I knew that
Thank you
you were
so
one
much.
of the best teachers. I could really feel that.
Yes,
No, because we
yes,
have done it with my own hands, all these things.
yeah, it could be felt. You could feel it. Yeah.
So
Thank you, sir.
officially we are closing up, sir. Here. Thank you so much. Namaste.
Thank
Have
you.
a nice day.
So, Omeo, please keep attending this lecture series
Sure,
and
sure.
tell our friends also.
Okay. Thank you.
Thank you.